long as we have earthquakes on Earth and landslides, the various phenomena that create tsunamis, we're going to have tsunami waves. It's just a matter of time when the next one strikes.
For generations, people believed the greatest danger came when the ground began to shake. But one devastating disaster shattered that belief in the most horrifying way imaginable.
From the South Sandwich Islands up through this region where some deep earthquake activities taking place, all the way up in the North American plate, we have seen sufficient movement here from this area of the Pacific Ring of Fire, the Pacific Plate.
The earthquake struck with little warning, yet the true catastrophe unfolded only moments later, as towering walls of water swallowed entire communities without mercy. Millions watched the unimaginable unfold in disbelief, wondering how everything changed so quickly. So, why did almost nobody see this deadly chain of events coming until it was already too late? The answer is more chilling than most people ever realized. The earthquake nobody saw coming. On August 12, 2026, instruments designed to detect the smallest movements of the Earth picked up a powerful magnitude 6.0 earthquake deep beneath the South Atlantic Ocean. The shaking happened thousands of kilometers away from the nearest populated areas, in one of the most isolated places on Earth. No cities trembled, no homes were damaged, no injuries or deaths were reported because there was simply nobody nearby to feel the ground move. To most people, it seemed like another ordinary earthquake in the middle of nowhere, an event that would come and go without attracting much attention. But that assumption could not be further from the truth. What makes this earthquake so important is not its size alone, but the place where it happened. It struck beneath the remote South Sandwich Islands, a lonely chain of icy volcanic islands surrounded by some of the roughest seas on the planet. Located deep in the South Atlantic Ocean, not far from Antarctica, this region is battered by freezing temperatures, violent storms, and towering waves for much of the year. Almost no one lives there, yet beneath its cold and empty surface lies one of the most dangerous and active geological zones on Earth. This isolated corner of the world sits where massive tectonic plates are constantly colliding, grinding, and sliding beneath one another. The enormous forces created by these movements build up silently over time before suddenly being released in powerful earthquakes. Scientists have long known that this region is restless, but it remains one of the least monitored places on the planet, making it especially difficult to understand what is happening beneath the ocean floor. That uncertainty is exactly what makes this latest earthquake impossible to ignore. Just 5 years earlier, nearly on the same date, this very region produced an extraordinary chain of earthquakes that shocked the scientific community. What first appeared to be a routine seismic event soon turned into something far more unusual. The earthquakes triggered a tsunami that raced across 3 different oceans, reaching coastlines thousands of kilometers away. Even more surprising, researchers later discovered that the earthquake sequence behaved in ways they had rarely seen before. It challenged long-held ideas about how large earthquakes unfold and left scientists studying the event for months in an effort to understand what had really happened. The magnitude 6.0 earthquake, recorded in August 2026, is not being described as another disaster. By itself, it is only a single event in a much larger geological story. Yet it comes from the same fault system that has already shown an unsettling ability to hide its true power until the consequences are already unfolding. In a place where the Earth's greatest secrets lie buried beneath miles of freezing ocean, even a seemingly modest earthquake can be an important reminder that the planet is always moving. And sometimes, its biggest surprises arrive without warning. What does the terrain of the earthquake site look like? What is the structure that predisposes the site to earthquakes? Let's find out. Where the Earth never sleeps. Far out in the icy waters of the South Atlantic Ocean, nearly 2,300 kilometers east of the southern tip of South America, lies one of the most remote places on Earth, the South Sandwich Islands. These islands are so isolated that no one lives there permanently. There are no towns, no roads, and no signs of everyday human life. Instead, towering volcanic mountains rise sharply from freezing seas, their dark, rocky slopes serving as home to more than 1 million penguins. To most people, the islands appear silent, empty, and almost forgotten. But beneath that quiet surface, the Earth is constantly at work. What can be seen above the ocean is only a tiny part of a much larger story. The islands themselves are the exposed peaks of a chain of underwater volcanoes created by one of the planet's most powerful geological processes. Hidden far below the seafloor is an active subduction zone, where enormous sections of the Earth's crust are locked in a slow but relentless collision. It is a place where unimaginable forces have been shaping the planet for millions of years, and where the ground is never truly at rest. Deep beneath the ocean, the massive South American plate is slowly moving westward and sliding underneath the much smaller South Sandwich plate. Every year, it advances by only about 65 to 78 millimeters. That movement may sound almost insignificant, but over the course of a single lifetime, it adds up to more than 4 meters of solid oceanic crust disappearing into the Earth's interior. This is not a sudden event, but a continuous process that never stops, day or night. As the descending plate sinks deeper into the Earth, it bends, twists, and fractures under crushing pressure. It carries trapped water and minerals far below the surface, where intense heat causes the rocks above it to melt. This molten rock, known as magma, slowly rises upward, feeding the volcanoes that form the South Sandwich Islands. At the same time, enormous amounts of stress build up along the boundary, where the two plates grind against each other. For years, decades, or even centuries, this pressure continues to grow, hidden from view beneath kilometers of ocean water. The sinking plate does not plunge straight down. Instead, it tilts into the Earth at an angle of about 45 to 55 degrees, reaching depths of at least 175 kilometers before gradually melting into the mantle. Yet earthquakes often begin much closer to the surface. On August 12, 2026, a section of this descending plate suddenly gave way at a depth of just 10 kilometers. In a matter of seconds, energy that had been building silently beneath the ocean floor was violently released, producing a magnitude 6.0 earthquake. A powerful reminder that even the world's most remote places are shaped by forces that never truly sleep. What does the impact of earthquakes look like? How do the variation in magnitudes manifest? Keep watching. The true power of earthquakes. One of the easiest mistakes people make when hearing about earthquakes is assuming that the difference between two magnitudes is small. In reality, the earthquake magnitude scale does not increase in a simple straight line. It follows a logarithmic scale, meaning that every whole number increase represents a massive jump in the amount of energy released. A magnitude 6.0 earthquake is not just a little stronger than a magnitude 5.0. It unleashes about 31 times more energy. Compare it with a magnitude 4.0, and the difference becomes even more astonishing. A 6.0 earthquake releases roughly 1,000 times more energy than a 4.0. What sounds like a tiny numerical difference is actually the gap between a noticeable shake and an event capable of producing tremendous force. To put that enormous power into perspective, scientists estimate that a magnitude 6.0 earthquake releases energy comparable to exploding around 15,000 tons of TNT in a single instant. That amount of energy is almost impossible to imagine. It is unleashed within seconds as enormous sections of the Earth's crust suddenly break free, sending powerful seismic waves racing through the ground in every direction. This particular earthquake became even more interesting because of where it happened beneath the Earth's surface. It originated at a depth of only about 10 kilometers, making it what scientists describe as a shallow earthquake. While 10 kilometers may sound deep to most people, it is actually quite close to the surface in geological terms. That matters because shallow earthquakes lose far less energy before their seismic waves reach the ground above. Instead of being absorbed and weakened by many kilometers of rock, much of the earthquake's energy travels almost directly upward toward the sea floor, making the shaking stronger near its source than it would have been if the earthquake had occurred much deeper underground. Even with that advantage, experts quickly determined that this event posed very little danger to people. The U.S. Geological Survey issued a green alert, indicating that the likelihood of deaths, injuries, or serious structural damage was extremely low. The reason was simple. There were virtually no communities close enough to experience dangerous shaking. The earthquake occurred in a remote location where its tremendous energy had few people or buildings to affect. However, that reassuring green alert tells only part of the story. It measures the immediate risk to human life and property, not the long-term potential of the region itself. It does not answer a much larger and more unsettling question. What could happen if a much larger section of the same fault suddenly ruptured? The fault responsible for this earthquake still holds the potential to produce far more powerful events in the future, reminding scientists that even a harmless-looking earthquake can reveal the hidden strength of the Earth beneath our feet. So, what was the most recent earthquake experience like on South Sandwich Islands? How did scientists perceive it? Stay tuned. The quake that fooled scientists. The South Sandwich subduction zone is home to the most powerful earthquake ever recorded in the Atlantic Ocean, and its history reminds scientists just how dangerous and unpredictable this remote region can be. In August 2021, instruments detected an enormous magnitude 8.1 earthquake, matching the size of another major earthquake that struck the same area back in 1929. At first, researchers believed they understood what had happened, but as more data became available, they realized the event was far more complicated and far more remarkable than anyone had imagined. The sequence began with a powerful magnitude 7.5 earthquake that struck about 47 kilometers beneath the Earth's surface. Because it occurred deep underground and hundreds of kilometers away from major coastal communities, experts initially believed it posed only a limited tsunami threat. But just 3 minutes later, the situation changed dramatically. A much larger magnitude 8.1 earthquake ripped through the shallower part of the subduction zone. Instead of ending within a few seconds like many earthquakes, this one continued shaking for an astonishing 260 seconds, more than 4 minutes. Over the following 24 hours, the Earth continued to rumble as dozens of strong aftershocks struck the region, including 3 powerful earthquakes measuring above magnitude 6. The tsunami that followed revealed a serious weakness in the world's real-time earthquake monitoring systems. Ocean waves spread across vast stretches of the South Atlantic and South Indian Oceans, eventually traveling thousands of kilometers from their source. Yet the first earthquake had confused scientists and automated warning systems, hiding the true size and nature of the second rupture. Because of this, the earliest tsunami warnings were based on incomplete information, and the full scale of the event was not recognized until the following day, long after the waves had already begun their journey across the oceans. Then came an even more astonishing discovery. In 2022, researchers concluded that the tsunami was actually driven mainly by a third earthquake, estimated at an even larger magnitude of 8.2. This earthquake occurred only about 15 kilometers beneath the seafloor, allowing it to lift and shift the ocean floor much more effectively. Even more surprising, it released its energy unusually slowly, making it difficult for standard monitoring systems to detect. One of the most dangerous parts of the entire sequence had remained almost invisible until after the tsunami was already moving across the sea. The magnitude 6.0 earthquake that struck the South Sandwich region in August 2026 occurred along this very same active fault system. Although scientists are not suggesting that a much larger earthquake is imminent, they continue to watch the region closely. Stretching for nearly 1,000 kilometers, this enormous subduction zone possesses the geological conditions capable of producing earthquakes approaching magnitude 9.0, making it one of the Atlantic Ocean's most closely monitored and potentially most dangerous seismic regions. But was the 2021 incident the first recorded earthquake in South Sandwich? When was the last recorded phenomenal earthquake? Stay glued. The quake that defied science. For decades, the massive earthquake that struck near the South Sandwich Islands on June 27, 1929, has remained one of the least known yet most remarkable earthquakes ever recorded in the South Atlantic Ocean. Although it happened in one of the world's most remote regions, modern scientists now believe it holds important lessons about earthquake behavior and tsunami risks that are still relevant today. Originally measured at a magnitude of 8.3, new research has confirmed that it was an exceptionally powerful event, making it one of the strongest earthquakes ever recorded in the region. What makes this earthquake especially fascinating is that it did not happen the way scientists once expected. Instead of occurring along the main boundary where two massive tectonic plates collide, the earthquake took place about 80 kilometers north of the northwestern end of the South Sandwich Island chain. Careful analysis revealed that it was caused by what is known as normal faulting, where part of the Earth's crust suddenly drops downward along a steep fault. Researchers believe this movement was triggered by a sideways tear in the South American plate, rather than by the enormous plate collision earthquakes that usually produce the world's largest tsunamis. This unusual type of fault closely resembles rare geological structures known as step, subduction transform edge. Propagator faults, which have also been identified near places like Samoa and the Loyalty Islands. Scientists also used advanced computer simulations to recreate the tsunami generated by the earthquake. At first glance, the results seemed reassuring. In the deep ocean, the tsunami waves were relatively small. However, as researchers looked more closely, they discovered something far more surprising. The models showed waves reaching nearly 30 centimeters offshore along parts of Brazil and about 20 centimeters near the Gulf of Guinea. While these heights may sound modest, they are large enough to create noticeable coastal flooding and dangerous run-up when the waves reach land. Perhaps the most important discovery was how the shape of the ocean floor changed the tsunami's path. Massive underwater features, including the South Atlantic Ridge, the Southwest Indian Ocean Ridge, and the Agulhas Rise, acted like giant natural channels, focusing and strengthening the tsunami's energy towards certain coastlines. Because of this effect, countries located thousands of kilometers from the earthquake, including Ghana, parts of southern Mozambique, and sections of South Africa, could experience stronger tsunami impacts than many people would ever expect. The findings completely reshape how scientists view tsunami hazards in the South Atlantic. Although the South Sandwich Islands themselves have almost no permanent population, powerful earthquakes in this isolated region can still send waves racing across the ocean toward distant shores. Most importantly, the study proves that devastating tsunamis are not produced only by massive plate collision earthquakes. Even earthquakes caused by normal faulting can generate dangerous ocean waves, highlighting the need for continuous monitoring, better hazard planning, and greater public awareness throughout the entire South Atlantic region. Has science really advanced to such an extent that earthquakes have become predictable? What could be making it difficult to anticipate earthquakes today? Stay with us. Scientists still can't predict earthquakes. For generations, people have dreamed of finding a way to predict earthquakes before they happen. Imagine knowing the exact day, place, and strength of a massive earthquake, days or even hours in advance. Such a breakthrough could save countless lives and prevent enormous destruction. Yet, despite decades of scientific research and some of the world's most advanced technology, that goal remains out of reach. According to the U.S. Geological Survey, USGS, neither it nor any other scientific organization has ever successfully predicted a major earthquake with reliable accuracy. Even today, scientists have no proven method to determine exactly when an earthquake will strike, where its epicenter will be, or how powerful it will become. More importantly, experts do not believe this capability will exist anytime in the near future. The USGS explains that a genuine earthquake prediction must answer three very specific questions. It must correctly identify when the earthquake will happen, where it will occur, and how strong it will be. Unless all three of these details can be accurately provided, it cannot be called a true prediction. This is why many popular claims fail to meet scientific standards. Stories about animals behaving strangely, unusual cloud patterns, mysterious body pains, changes in radon gas levels, or groups of small earthquakes are often shared as warning signs. While these events may sometimes happen before an earthquake, they also occur countless times without any major quake following. On the other hand, many devastating earthquakes strike without showing any of these supposed warning signs at all. Because these patterns are inconsistent and cannot be repeated reliably, scientists do not consider them dependable evidence. Rather than trying to predict the impossible, researchers focus on something far more realistic, estimating the likelihood of future earthquakes. By carefully studying fault lines, the movement of Earth's tectonic plates, and records of past earthquakes, scientists can calculate the probability that a strong earthquake could occur in a particular region over the coming years or decades. These long-term forecasts do not tell people the exact day or hour disaster will strike, but they provide valuable information that helps governments improve building standards, engineers design stronger structures, and emergency agencies prepare communities before tragedy occurs. The USGS also makes an important distinction between earthquake forecasting and earthquake early warning. These are not the same thing. Early warning systems do not predict earthquakes before they begin. Instead, they detect an earthquake the moment it starts and quickly send alerts to people who are farther away from the epicenter. Depending on the distance, those alerts may provide just a few seconds, or in some cases several tens of seconds, before the strongest shaking arrives. Although that may seem brief, it can be enough time to stop trains, shut down critical equipment, and allow people to take protective action. Until science discovers a reliable way to predict earthquakes, experts agree that the best defense is not prediction, but preparation. Stronger buildings, better emergency planning, public education, and resilient infrastructure remain the most effective tools for reducing damage and saving lives when the ground begins to shake. Are there possible natural phenomena, aside from earthquakes, that are associated with the South Sandwich Islands? Could the geological structure of the South Sandwich Islands predispose the area to many natural disasters? Keep watching! The volcanoes refusing to sleep. The South Sandwich Islands are far more than a remote group of icy, windswept islands. Hidden deep in the South Atlantic lies one of the most active volcanic chains on Earth, a place where the ground is constantly being reshaped by powerful forces beneath the ocean floor. While few people have ever visited these islands, the volcanoes that rise from them have been anything but quiet. Scientists have recorded eruptions from at least 6 different volcanoes across the island chain, making this one of the planet's busiest volcanic regions. Since 1819 alone, at least 13 confirmed eruptions have been documented, averaging nearly 1 eruption every 15 years. Even more remarkable, throughout recorded history, one of these volcanoes has been erupting somewhere in the chain about once every 3.5 years. At the northern end of the islands sits Zavodovsky Island, the most active volcano in the entire chain. When Russian explorer Fabian von Bellingshausen first reached the island in 1819, the volcano was already erupting, as if welcoming him with fire and smoke. Nearly every expedition that followed reported the same sight, a smoking summit sending gases into the freezing sky. Its most recent confirmed eruption came in 2016, when towering clouds of ash and steam burst into the air. Satellite images later revealed that fresh volcanic ash had blanketed nearly half the island. That same year, nearby Bristol Island also erupted, producing enough volcanic activity to force maritime authorities to issue navigation warnings for ships passing through the area. Farther south rises one of the chain's most extraordinary volcanoes, Mount Michael on Saunders Island. Standing 843 meters above sea level, it hides one of Earth's rarest natural wonders, a permanent lava lake. Unlike volcanoes that briefly fill with molten rock before cooling, Mount Michael's crater contains a lake of glowing lava that remains continuously molten. Even now, while few people are aware of its existence, a pool of liquid rock bubbles inside its summit, kept blazing hot by magma constantly rising from deep below, where tectonic plates collide. Scientists believe Mount Michael has remained in continuous eruption since at least 2014, making it one of the world's few volcanoes with such long-lasting activity. The volcanic story continues farther south on Montague Island, home to one of the largest volcanoes in the South Atlantic. It has also produced several confirmed eruptions over the past century, reminding scientists that the region remains intensely active. These volcanoes are not ancient mountains that have long fallen silent. They are living, breathing geological systems, continuously fueled by the movement of tectonic plates beneath the ocean. The very same underground forces responsible for these restless volcanoes also generated the recent magnitude 6.0 earthquake, proving that beneath these lonely islands, the Earth is still very much alive. But how much have scientists been able to explore and discover about the South Sandwich Islands? What could have contributed to the mystery? Stay with us. Earth's least understood tsunami threat. The South Sandwich Islands occupy one of the most important earthquake zones on Earth, yet they are also among the hardest places for scientists to study. Their extreme isolation, harsh weather, and icy location in the far southern ocean create enormous challenges for researchers. Unlike many of the world's active fault zones, these islands have no permanent seismic stations to record earthquakes where they happen. There are no GPS instruments constantly measuring how the ground shifts before and after major events. Thick clouds, powerful storms, and their location near Antarctica often block or reduce the quality of satellite observations. As a result, much of what scientists know about this massive subduction zone comes from instruments located hundreds or even thousands of kilometers away. In many ways, researchers are trying to understand one of Earth's most dangerous geological systems while standing far from the scene. The massive earthquake sequence of 2021 clearly revealed the problems caused by this lack of monitoring. The event generated a tsunami that traveled across 3 different oceans, yet scientists did not immediately recognize which part of the earthquake sequence had actually produced the largest waves. It took detailed analysis after the event to uncover what had really happened. That delay highlighted a major weakness in our understanding of this remote region. Despite its ability to produce enormous earthquakes and ocean-crossing tsunamis, the South Sandwich subduction zone remains one of the least observed active plate boundaries anywhere on the planet. Ironically, its scientific importance is matched only by how difficult it is to study. The consequences of this limited knowledge stretch far beyond these lonely volcanic islands. The tsunami generated in 2021 was detected across large parts of the South Atlantic and even reached the Indian Ocean. Although the waves were relatively small, with the highest coastal measurement reaching about 75 centimeters on South Georgia Island, nearly 800 kilometers away, the event demonstrated how far tsunami energy can travel. Underwater mountain ranges, deep ocean basins, and hidden ridges can redirect and concentrate wave energy in unexpected ways, sending it much farther than scientists once believed possible. If an even larger earthquake were to strike this same region, predicting the size and path of the resulting tsunami would still involve significant uncertainty. Computer models of the powerful magnitude 8.3 earthquake that struck in 1929 suggest its waves may have reached coastlines thousands of kilometers away, including parts of South America and West Africa. When those historical models are combined with the real-world observations from 2021, they paint a clear picture. The South Sandwich subduction zone is not simply a remote geological curiosity. It is a genuine source of long-distance tsunami hazards whose full potential is not yet fully understood. What more could have made the South Sandwich Islands one of Earth's most active geological regions? Could this be the reason why the region is left without inhabitants? Let's find out. Where Earth's giants never sleep. Beneath the stormy South Atlantic, the remote South Sandwich Islands sit atop one of Earth's most active geological regions. Although the islands appear quiet and uninhabited, immense tectonic forces have been shaping the area for millions of years. The South Sandwich Plate is constantly created at a mid-ocean ridge, while simultaneously sinking beneath another plate through subduction. Trapped between the South American, Antarctic, and Scotia plates, it experiences enormous pressure that fuels frequent earthquakes and volcanic activity, including Mount Michael. The descending slab reaches nearly 850 kilometers deep, making this one of the world's deepest and most remarkable subduction zones. The magnitude 6.0 earthquake that struck on August 12, 2026, is only the latest reminder that this region never truly rests. It followed a magnitude 6.4 earthquake just a few weeks earlier, continuing a long history of frequent seismic activity. Yet history also reveals that this area is capable of producing far more destructive events. In 2021, a massive magnitude 8.1 earthquake shook the region after a smaller foreshock occurred only 3 minutes earlier, demonstrating how quickly a seemingly moderate earthquake can grow into a major disaster. Even earlier, in 1929, the region experienced an even larger magnitude 8.3 earthquake. Despite these powerful events, scientists caution against assuming that every earthquake signals an even bigger one is about to happen. Instead, the recent activity simply confirms what researchers have long understood. This remains one of the world's most active tectonic regions. Some studies suggest the fault system could, in theory, generate an earthquake approaching magnitude 9.0, although experts still do not know whether enough stress can actually build up to produce such an enormous rupture. Although the South Sandwich Islands themselves have no permanent residents, the greatest danger lies far beyond their shores. A powerful earthquake beneath the ocean can generate tsunamis capable of traveling thousands of kilometers, threatening coastlines in South America, West Africa, and other distant regions. Because these earthquakes occur in such an isolated and complex part of the world, early warning systems may initially underestimate the size of the tsunami, allowing dangerous waves to spread across the ocean before the full threat is recognized. Rather than signaling an immediate catastrophe, the August 2026 earthquake serves as another powerful reminder that Earth's interior is constantly in motion. Deep beneath the ocean floor, tectonic plates continue their endless struggle. Rocks fracture under immense pressure, magma rises toward the surface, and stress quietly builds year after year. These unstoppable natural forces have shaped the South Sandwich region for countless ages and will continue reshaping it long after today's earthquakes have faded from memory. So, what do you think about the earthquake no one saw coming? Do you think scientists will soon predict earthquakes? We'd love to hear your opinions in the comments below. And don't forget to like and subscribe.